Welcome to my course, Game Development Basics, Week 8, Lesson 4, Procedural Level Generation. So here I am in my bug swash game that we made in Week 2 of this course. And we can see when I press play, quite a bit has changed. When we left this project at the end of Week 2, it was a very basic game, and we can see that a lot of improvements have been made. And there were actually so many things that I changed in this game that I decided to break it up into 2 lessons. In this lesson, we're going to talk about how we built out this level procedurally and how this will create a dynamic play experience for the player. So every time we launch this game, the map is going to be a little bit different. And we can see here in my level that there's really nothing in the game right now. It's just some lighting, a nav mesh, and my player start. But when I press play, this entire level is being built up for us from nothing. So let's talk through how this is being done. I'll show you on my game instance. I just have one variable for now, and that's grid size. And this will allow us to dynamically change the size of our map in the game. So you can use this in your game to set up different levels. Maybe there's different sizes. Maybe you want to have a smaller map for quicker battles or a much larger map for a longer battle. During my playtesting, I found that 30 seemed to be a good size to make for a fun play experience without being so large that the gameplay slowed down. I wanted this to be a fast-paced arcade-style game. So let's just break down how this is working. In my game mode, on begin play, we're just going to do some boilerplate stuff. We're going to set our player character variable. We're going to create the main menu. And then we're going to call a function that I called create map. Now in here, right off the bat, we see that we are getting our game instance and getting that grid size. And then I set it to a variable on my game mode. Now you don't have to do this. You can continually just pull the one from game instance. In that case, I recommend setting game instance as a variable instead. But because this is the only time that we're going to need this, I just have it pull it from the game instance and then set it to a grid size on the game mode. Then we're going to do a sequence. The first thing we're going to do is we're going to reset this doN node and then call doN. And we can see that this is a loop where the n is the grid size. So in our case, in our game instance, it was set to 30. So we're going to call make row, and we're going to do this 30 times. But we're also going to pass in the current counter as a variable into make row called row. Now here in make row, we're going to do again a sequence where we're going to reset the doN, and then we're going to do n with the number of times of the grid. And we're taking that n and we're going to set it to a local variable called column. Now we have 2 variables in this function, a row, which came in from our create map function, and a column, which we created based upon grid size again. So this will always make a square map. Now, if you wanted to have different shapes, you would have to set this up a little bit differently, but you could have this set up rectangles or circles or various different map types if you did a little bit different math. And in here, there's a few different branches, and I'll just walk you through what these are doing really quickly. So the first branch is going to check this is at border function. And this takes 2 inputs, a row and a column, which we had set in this function. And what this is doing is it's going to check if our row or column is at the edge of the matrix. So if our row is equal to 1, or it's equal to the grid size, which means it's either the first or last row, and then we'll do the same for column. We'll check if it's equal to 1 or grid size, which will give us either if it's the first or last column. And if any of these are true, we're going to pass true using this OR node. So if they're true, we're going to call spawn actor of type wall. And BP wall just has one element. It's just a static mesh. And there's also this variable called random mesh, which is an array of static meshes. And we can see that we set 4 different static meshes in this array so that we have a variety of options to choose from. So on begin play of BP wall, we're going to get that array and we're going to get a random element and we're going to set the static mesh to that new mesh. And this will allow some variability in the way our walls look in our game. It just makes it a little bit more interesting to the player. But we need to know where to spawn it. So there's a new function called getBlockSpawnLocation, and this is going to take an input of our column and row. Now in here we have a variable called block spacing. This may need to be adjusted based upon the size of the actor you're spawning in. So here I have that static mesh. I set the scale to ×2. That way they were a little bit larger and I was having to spawn less of them into the level. So we'll notice that my block spacing is set to 200 because we made it twice as large. But you may need to adjust this depending on what mesh you use for your procedural level generation. We're going to take block spacing and multiply it by our column, and we're going to add this to the output of another function called getStartingPosition. In here, we're taking our grid size and we're multiplying it by block spacing. And then we divide it by 2. And this will give us a number that is the total units away from the center that we need, and then dividing by 2, because we want 0, 0 to still be the center of the map. Then we're going to add that to another variable, which is block spacing divided by 2, and this will offset it so that these are slightly off center when our map is spawned. And we can see that here that the 0, 0 location is where 4 of these blocks will meet. And then we're going to multiply it by -1 because we're starting at the top left corner, so we need to multiply it by -1 so we get a direction in the negative. And all of that is going to give us the x coordinate where we're going to spawn this block. For the y coordinate, we'll take the row input, we'll multiply it by block spacing, then we'll get that starting position again and multiply it by -1 to change the direction of it. And then we'll take that and subtract the block spacing. And all of this will give us the y location of this vector. And by setting up the function this way, we can reuse it when we're spawning the floor variables in. So all of that is creating the outer wall. This next check is checking is not at center. Now when we start our game, I always want to be able to spawn this tower directly at the center of the map. But I want to make sure that there's not going to be any obstructions at the center. So I set up a function called isNotAtCenter, which takes an input of a column and a row again. And here it looks like we have a lot going on, but I'll break it down for you quickly. Ultimately, our goal is to see if we're at the center of the map so that we're not spawning an obstruction where our tower is going to be. So I have a not and then an or. So this is going to say if either of these return a 1, we're going to swap it to a 0. And what are these doing? We're checking if a flow is in range. And there's 2 of them. We're going to pass in our row and column to these, and then we're going to get a min and max value. And we're basing all of this on a center radius that I have set up as 2, which would mean we are not going to spawn anything in these middle 4 cubes or the cubes directly adjacent to those. And you can change this to be a larger or smaller radius depending on what you're doing in your map. So we're getting our grid size and we're dividing by 2, and this will allow us to find the center of the map, and then we'll have this as a plus or minus, as a min or max based upon the center. And if any of those are true, we'll reverse it so that we can say we are not at the center of the map. And we'll see here that the false of this goes to spawn actor BP floor, which means we're always going to spawn a floor actor if we're at the center of the map. Now, the floor actor is very similar to our wall actor, except for that we're always going to have the same floor mesh for any floor actor. And we'll see that the root of this is at 0, 0, so the floors will be spawning below, whereas with our wall actor, the root is at the bottom of the mesh, so the mesh will be spawned upwards. So whenever we're spawning a floor, we're going to get the same spawn location. We're going to spawn an actor of type floor, And the only difference here is that we also have an array called floor array, and we're going to add this to that array. And we'll see why this is relevant in the next lesson. But for now, we just need to know we're creating an array of all the floor actors that we can use for other functionalities in the next lesson. And the last thing I wanted was to have some of these little walls sticking up from the map to make the map a little bit more interesting and dynamic. And that's handled by this function here, is random location. And I set this up to take a randomness value, which is the percentage of time that we're going to create a random wall in place of a floor. And currently it's set to 4%. But if we increase this to something like 50, we can see now that substantially more of the blocks are being made into walls. And in this case, it's half of all of them are walls. You can experiment with this as you like. I found a smaller number was able to provide some randomness without making it overwhelming or creating situations where the bugs could get stuck. And if one of those is turning true, then we'll spawn a wall, otherwise we'll spawn a floor. And once that loop is complete, we're just going to spawn a castle tower at the center of the map. And that's everything that is going into doing this procedural level generation. But let's review again really quickly just to make sure that we covered everything. So in our game mode on begin play, we're setting up some boilerplate functionality, and then we have this function called create map. In here, we're getting our game instance, and then we're getting a grid size variable and setting that to the grid size on our game mode. We're going to do a do n with the input of n being grid size. And then we'll take the counter and we'll pass that in to a function called make row and call that row. In here, we'll take grid size and make it into a variable called column, and this will be a local variable. And our goal here is to spawn one of two actors, either a floor, which will be also saved into a floor array, or a wall, which creates some obstructions for the players and enemies. So the first thing we want to do is we want to create a wall around the border of the map. And this makes it so that the enemies and the player can't fall off the world. So what we're going to do is at border, and this is just going to check if the row or column is either the first or the last row so that we can make a wall. So if that's true, we're going to spawn BP wall. The next thing we're doing is making sure that at the center of the map, we're always going to spawn a floor, and that way there's no obstructions for the player or the tower directly in the center. And this function is finding the middle of the map and then an offset of center radius, which I have set to 2. So if the row or column is the centermost element or the element directly around that, we're just always going to spawn a floor there. And the last branch is getting some random locations to spawn obstacles. And in here, we just have a randomness value, which would be a percent of times that we want a random obstruction to be spawned. So we're getting that percentage and we're dividing it by 100. And then we're checking if that number is less than 1, which would mean we do want to spawn an obstruction, in which case we'll get true here and we'll spawn a wall instead. And all of that is what's allowing us to create these dynamic maps that change every time based upon some input variables. And this is really the key to procedural level generation. Now, obviously, this is just one implementation of procedural level generation, and it's a pretty basic one at that, but it should allow you to start thinking of how you would create a procedural level for your game or any other game. But obviously this game is still quite different than where we left it off at the end of week 2. So there's a lot more things that we need to go over, and we'll be handling the rest of these in the next lesson.